Hi, and welcome to the second week of Machine Learning and Data Science course, which is a 10 module course which is designed in a way that will help you to get the basics of machine learning and data science clear as you advance through each module. So this week we are going to be discussing some advanced libraries of Python that we are going to be using throughout this course, such as NumPy and pandas that are used for accessing the data, manipulating it, performing various operations over it, and other than that, Matplotlib and Cbond. These are used for actually visualizing the data, how the data looks on graphs and charts and everything, and other relations related to data as well. Other than these, we are going to be using other libraries such as SciPy and scikit-learn, all these as well. Other than that, we'll be using frameworks too, like TensorFlow and Keras. But for now, we'll limit our discussion to these four libraries only: Panda, NumPy, Matplotlib, and Cbond, because these are the basic libraries that are going to be used in every module, and the rest libraries won't make much sense of as of now, because those libraries are actually dependent on their application, and right now we aren't going to be understanding much of the application. These are basic things like visualization, graphs, and everything that we already know, and some mathematics and data manipulation that we can perform without much knowing about the concepts. So before starting with the tutorial, I'd like to first address one thing, that for those of you who haven't installed Anaconda, I would suggest you use one other thing that won't need any install on your system, that is called Collab. It's basically online platform by Google where you can perform all the operation that Anaconda lets you, but in an online format. So the same notebook format that you get over Anaconda, means Jupyter Notebooks, you can access directly on the cloud through Google Colab. All it will take you is to change your runtime, make it as per your preference. If you are going to be using it for deep learning and all those things, make it TPU, but as of now, let's keep it GPU, and then just connect. This will start your runtime. One benefit of this is that you get allocated more RAM than you might get on your local system. For example, right now it provides you with 12.5 GB or something. But as the program grows, means if your program might grow out of that limit, then it will expand your RAM capacity as well. And in addition to that, you get online storage. You can mount your Google Drive and directly start to work on it. So like running anything that we might run on Anaconda would run here as well. So yeah, that's for those of you who haven't installed Anaconda and want to still keep up with the course. So directly jumping into the tutorial. So for NumPy, I would I would teach you some basic functions of NumPy. Not much to know there. And for pandas and Matplotlib and Seaborn, we'll see see an example of Boston housing data. It is one of the famous easily available housing data out there, and it's free to use, so you can directly Google it and download it. So other online resources are there where you can download these type of free data. For example, one interesting one is Google's Kaggle. So if you know about Kaggle, well, it's basically a website that is hosted by Google, and it hosts competitions and things like that. So it contains various data sets that you can directly access. Other than that, even governments provide data. Indian government also provides free data. US government provides free data. So those data can also be accessed, but they are mostly big data and not for you to start with. For example, some of the data are just tables, long and long, so long that even they can be of 20 GB, 30 GBs, and all the sizes. So I would like you to start with a fairly smaller data, so that it doesn't get too crowded and you don't mess things up. So NumPy. So let's go ahead and import all the libraries first. Import NumPy as NP. So again, this is aliasing, means I'm changing the name of NumPy as NP. I won't have to call NumPy, I will have to call NP. So NumPy provides various mathematical, linear, algebraic, and matrix related functions, As you can see, some of the functions that NumPy provide are these. Actually, these are all the functions. We'll be basically focusing on matrix related function of NumPy, because that's what we are going to be using throughout the course mostly. And some other than that, we are going to be using the linear algebra related functions and all those things. So yeah, so how do you create a matrix in NumPy? So for example, if I have to create a 2D matrix without NumPy, how would I create it? Something like this, using lists in Python. So let's say, so as of now, if I print m, this is what m looks like. So if I have to convert this into a NumPy array or NumPy matrix, I will have to enter this. What it will do is it will convert the particular list or nested list into an array of 2 dimensions. So you can see it's a 2 dimension array, means it has 2 rows. So it means it has rows and columns, and for this particular case it has 2 rows and 2 columns. If I have to extend it, I can just extend it like this. So now it has 2 rows and 3 columns. So yeah, the basically matrix in NumPy or any of the matrix structure in NumPy is represented as a data structure that is native to it, known as NumPy arrays. So if I go ahead and store it in m and ask for what is the type of m, it will say NumPy nd array, means n dimensional array. So n dimensional array is basically representation of any array, and if I have to know what dimension it is in, so I will have to do in name of that array and shape. So it will return a tuple with the first value of the tuple, or the 0th index of the tuple, as the number of rows, and the first one as the number of columns. So this is basically how you create a NumPy array. Other than this, the basic matrices that we all know are one matrices. So one matrix is 0 matrices, so np dot ones, and you pass in the shape. So it will create an one array of shape 1 comma 2, so 1 row and 2 columns. If I just go ahead and do something like that, it will create 5 rows and 4 columns. So that's how you create arrays of one. You'd be wondering where we will be needing something like this, or maybe even something like zeros, 4 comma 5, something like this. So these can be used as filters for various operations later on, or even as one hot encoding and things like that. You'll understand those things as we go along and learn those concepts, but for now these are the basic operations that NumPy lets you perform. Other than this, identity matrix in NumPy can be declared as this. So identity matrix is nothing but a 2D matrix or 2 dimensional matrix which has equal number of rows and equal number of columns, and the diagonal elements are all ones and other elements are zeros. So you would be wondering, why not we write all these things, and why not we directly perform this on list and these functions directly using the normal function, or right from the scratch? The very basic reason is that we are lazy and we don't like to do that. And other reason is that even if we try to do that, I don't think any of us would be able to write, or even if we are able to write, we won't actually like to waste much time on writing all those codes which NumPy can actually perform better. So what happens is, NumPy or pandas and all these libraries are well tuned, and they take advantage of multiprocessing and threading and all these things. So that's why they actually perform quite better than any function or anything that we write from scratch. So just for example, let's do one thing. Geeks for geeks. So matrix multiplication or dot product is something we are all familiar with, and yeah, so NumPy provides us with a basic function that lets us perform this operation on the NumPy, what we call as the NumPy array. So I'll just go ahead and copy this, paste it here. So what I'm going to be doing is, we'll compare the time that this normal function takes, and then we'll be computing the time that the NumPy function takes to perform the same operation. So let's go ahead and let's say let's just return this multiplied array. So what this function will be doing, it will be taking two matrices, multiply them and return the result now. So basically that. So this returns the whatever the array that is multiplication of m and n. So let's do one thing, take this out and import time. So time is a basic module in Python that you can import, and I'm going to be using time.time. What this will do is it will return the time of execution at which this particular function is executing. So I'll put that in start, then I'll execute the function, then I'll ask how much time it took. So start will get subtracted from the current time. Start is the time when the function starts to execute, and this is the difference between the time right now and when the function started to execute. So as of now 0 point something like that, so it's not even a second for multiplying that array. So now let's see how long NumPy takes for it. So what I'll do is I'll convert these two into NumPy arrays. So m becomes np dot array of m and n becomes np dot array of n. So yeah, now again I'll copy this, paste this. In NumPy, to multiply two matrices, what you have to do is the first matrix, then dot, then the second matrix. Now let's see. As of now, you can see that it is taking 0002 and it's taking 0004. So we'll say that that function is actually faster than this function. So to go ahead and demonstrate that it's actually not, for I in range, let's for now say, okay, let's go ahead and say 5000. What I'll do is I'll multiply these two matrices, put it at m, store it in m, then again multiply, and this will go on for 500 times. So after 500 times 5000 times, it's 0.67 seconds. Now let's do the same for NumPy. Okay, so what happened is that these two matrices got multiplied. Okay, I'll have to again reinstantiate these two. So these are the initial values of m and n. It's taking 0.66 second. Again initial values, again changing them into NumPy array. Yeah, so now as you can see, it's taking 0.66 second, it's taking 0.01 second. Now if I go ahead and make it a little more complicated, as you can see, it's still running. I don't even know if it's going to compile well or not. Let's stop. So as you can see, the number of iterations, when we increase the number of iterations, the normal function or the scratch written function actually was taking so long that it couldn't compile in the given time, while it took NumPy just 0.12 second to compile and give the result. So that's the basic difference why we use NumPy rather than the basic functions that we write from scratch. Okay, so one important feature of NumPy that I'd like to discuss is known as broadcasting. So what broadcasting is that many NumPy arrays, or maybe even normal 2D matrices were found with the list, nested list application. They can be of different shapes. For example, if I go ahead and see what M looks like right now, okay, let's do one thing. Copy this, paste it here, and change it into a numpy array. So now m is basically this, and the shape of m is 4 comma 4, right? So if I had to normally go ahead and multiply for, let's say, if m is of 4 comma 4 and I had another array, for example, let's just go ahead and say np dot zeros uh, of size uh, let's go ahead and do it row wise. So we'll keep 4 number of rows and 1 number of columns, so it will be something like this. Now if I had to multiply it naturally, when we do it naturally, what we do is we multiply this particular column with the entire first column, then the second, then the third, then the fourth. This is how we do it normally, right? So if I have to write a program for it, I'll have to iterate over this, and so on, like that, right? So rather than doing that, we can directly go ahead and multiply these two through something known as broadcasting in Python. So m into n would result in this, because what NumPy is doing, it automatically is taking the zeros and multiplying with this, then this, then this, then this. Normally this won't be possible, because then we'll have to iterate over all those columns. What NumPy does is NumPy simply creates 4 clones, because there are 4 number of columns here, so it creates 4 clones and then multiplies it with all of them. So if I had something like let's say another array, simple, just numpy dot array of 1 comma 1, let's say it has 2, this would be our m again. So this would look something like this. 1 is multiplied by 2 is 2, 2 multiplied by 2 is 4, 3 multiplied 6, and 8. So it's multiplying with each and every element of the array now, because the shape is 1 comma 1. So NumPy will automatically judge how to actually multiply it, so you won't have to much think about it. Other than this, NumPy has this functionality called as transpose, that is basically matrix transpose. So how to find transpose? So let's say it's stored in Z, and right now Z looks something like this. So if I had to find the transpose of it, what would the transpose be? All these twos will be shifted as column, all these four as the another column. So Z dot transpose looks something like this, right? So if I have this, then there's another function in NumPy known as reshape. What reshape does is some people confuse reshape and transpose. The difference between let's first go ahead and see what reshape does. So if I right now the shape is 4 comma 4 for Z, and if I go ahead and reshape, it doesn't change as much. So 4 comma 4 is basically 16, right? So 16 can be equal to 4 into 4, or it can be equal to 2 into 8, or it can be equal to 8 into 2, and 16 into 1 and 1 into 16, right? So these are the possible variations for getting 16 out of means a 2D vector or 2D matrix. So reshape can perform this operation and reshape your 4 cross 4 matrix into any of these shapes. For example, if I go ahead and put a valid shape that is 2 comma 8, it will convert it into 2 comma 8. What it basically does is every time we means we want to reshape, what it does is it converts it into a long series or a single array of 1 comma the entire shape that is there. So 4 comma 4 is 16, so it will convert it into 1 comma 16. Right now I'm doing it, but behind the scenes the NumPy does it automatically. It converts it like this. So if I put 2 cross 8, if I go ahead and 2 cross 8, what happens is it knows that we want 2 rows of 8 columns. So it takes first 8 columns and makes it the first row, then it takes another 8 column, means another 8 values, and make it the second row. So we get something like this. So it starts from 1 comma 16, then it goes ahead and changes it into 2 comma 8. So that's what happens behind the scenes. So do not get confused between transpose and reshape. They might perform similar kind of operation, but they are entirely different, not entirely different, but they have some functionality that if you don't look at carefully, then you might make some mistake. So this covers the basic functionality of NumPy arrays, and it's fairly easy because they behave normally as the matrix in mathematics does. So yeah, there's not much to ponder about in for NumPy, the basic NumPy. Other than this, there is going to be linear algebra and all these things, but those things will be covered as we go along, and we need them during writing various algorithms from scratch. So after this, let's go ahead and start looking at the Boston housing data.